This is how I gave wheels to my laptop. We humans are lucky to have legs, we can move around and enjoy life. It is an extension of our free will. So that makes me think, our poor computers start to have intelligence but no body. This is why I want to make something special for my laptop. I want her, yes, it's a her, to be able to move laterally to follow my face when I move to the left or right, and also longitudinally to go forward or backwards when I distance or get too close. I don't want to get into complex drive mechanisms, so I decided to use Mecanum wheels. Mecanum wheels are special because they allow robots to move across two axes. They have small rollers at 45-degree angles that allow them to combine and cancel out forces, giving them the power to go any direction they want. The first thing I did for this build was to design some Mecanum wheels on Fashion 360 to manufacture them on my 3D printer. I included the characteristic double D shaft shape of the DC-TT motors we will be using. As you can see, there's also some holes to insert some screws and to make the whole structure stronger. If you want to review the design by yourself, you can click on the links in the description. They will lead you to my personal project, QuickView. QuickView allows creatives and professionals to quickly share their 3D designs with both technical and non-technical clients. It is optimized for mobile phones, and I recently included a password protection feature for maximum security. You can visualize models locally or share them with a simple link. Go and check it out. The next thing I did was to go to my local bike shop and ask for some spokes. They make up for great shafts and are not that expensive. I mark them every 5 centimeters and cut them. You might think we could just assemble the rollers right as they are, but you would be not considering the fact that they are soft in texture, providing almost no friction. To give them a bit more grip, I'm covering them with 1-inch heat shrink tubing. The half-inch was too small for it, and I found no in-between, or at least a 1-inch one with a greater shrink ratio than 2:1. That's why I have to apply a lot of heat, and as you can see, it is not optimal, but it works. I'm using a small candle as a source of heat, since I tried to use a lighter, but it literally exploded from the continuous heat. I used a leftover spoke as a shaft and another one as a stick to help me roll them like marshmallows and avoid burning myself in the process. Now that we have all of the wheel parts, we can start assembling them. I start by connecting the flowers with screws and nuts and follow by inserting the rollers with their shafts. To ensure shafts stay in place, I apply some super glue on them. With all of the Mecanum wheels assembled, we can move to the electronics. The first task was to solder the cables to the TT motors. It was way harder and messy than I expected since my soldering iron was recently exposed to a lot of plastic. I'm using an Arduino Uno board as the brain for the robot and a L29 3D motor shield to handle the motors under voltage. I have a rule of avoiding silicon as much as possible, and I feel very bad for breaking it to keep the motors on their place, but it was very tempting to do it that way rather than building or getting some supports. I found a small piece of wood, and that's what we are using as a base. We finally reached the point when it is time to test everything together. I'm using a test code by Adafruit to ensure that all of the motors are working and rotating in the right direction. It is standard that all of the motors spin in a clockwise fashion when applying positive voltage, and as you can see, not all of them did, so we had to invert the polarity. I haven't mentioned it yet, but we are using OpenCV on Python to detect my face. To make things quicker, I used Gemini to give me the code, and I made the necessary changes to fit the wheel's arrangement. If my face is recognized between a safe area and the center, nothing happens. This is the first time I'm testing everything together, and the robot is upside down to reduce variables. As you can see, the lateral movement works wonders, but the longitudinal movement seems a bit shy. I hope the motor's torque was enough to handle the weight, but it seems it was not. When I lift the laptop, the motor's force is enough for the robot to distance or get close to me. It was a bit disappointing, but the project in general was great, and I hope you liked the video. This is my first one, so I invite you to like it and subscribe.